Hi all, it's Dave Giles here again with the second lesson on IGCSE Thermal Physics for Cambridge International IGCSE. And today's lesson is on gas pressure. So the learning objectives for today are describe what causes pressure in gases, which is a very brief learning objective. And the majority of today's lesson will be focused on the second learning objective, which is describing and explain how to change the pressure in a gas. So to start us off, I've put on a past paper 2 exam question, multiple choice. And the question is just, why can a gas be compressed easily into a smaller volume? And the reason for that is the particles being far apart, as you can see here. So focus on the first learning objective first, describing what causes pressure in gases. So gas particles are moving randomly at high speed. They exert a force each time they collide with the walls of the container. Now, I'm going to really emphasize that bit there, the walls of the container. So it's the collisions with the outside bit, so in this case here, the balloon, which is causing the pressure. Okay. Gas pressure, gas pressure arises due to these collisions. And just to really emphasize the point here, when gas parts collide with the walls of the container, they exert a force on the walls. So that was the first learning objective. So I'm going to do a very quick past paper 2 exam question on that. So a fixed mass of gas is trapped in a container. The temperature of the gas is increased, but the volume of the gas is kept constant. How does this change affect the average kinetic energy of the molecules and the pressure of the walls on the container? Well, the pressure will increase and the average kinetic energy will also increase. So the answer is A. So that's the first learning objective complete. The second learning objective is about describing and explain how to change the pressure in a gas. So if more gas is pumped into a container, then you get more gas particles per unit volume. So you're going to end up getting more collisions with the wall of the container, which will increase the pressure inside that container. Similarly, with volume, if I decrease the volume, so I make it smaller, there's still going to be more gas particles per unit volume. So the thing we're changing now is not the gas particles. We've got a smaller volume, so there's more gas particles per unit volume. The gas particles collide with the walls of the container more frequently, which causes the gas pressure to increase. The last little thing to look at with regards to increasing pressure is temperature. So if a gas is heated up, the particles gain kinetic energy, which means there are more collisions with the wall, and each collision also has a greater force on the wall. So that increases the pressure in there. So they've got a higher speed, higher kinetic energy. They hit the walls of the container more often and with greater force, which increases the pressure inside the container. So just to summarize, if I've got more gas, I've got more pressure. As the temperature of gas is bigger, I've got more pressure. And if I make the volume bigger, that reduces the pressure. So here I've got a system it's a piston with a container, and that piston can be closed. And what 2 things happen as I press the piston down? Well, firstly, I reduce the volume of the container, which in turn here you can see when I've reduced the volume, I have increased the pressure. And I've got a table here of the volume and the pressure I get with each volume. And if you multiply pressure and volume together, you'll see that it's the same. It's a constant. So this leads to Boyle's law, which states that pressure times volume is a constant. Here's a little caveat to that, which is that provided the temperature stays the same. Okay, so provided temperature stays the same, pressure times volume is a constant. And here it's 60. I haven't gave it units because I don't know what pressure or volume units I'm using here. So two quick questions here. So as pressure increases, volume decreases. As volume increases, pressure decreases. So if we plot pressure against volume, we get this shape graph. And I'm actually going to put some numbers to the graph now. So here I've got a pressure of 50 pascals and a volume of 20 meters cubed. Here the pressure is 25 pascals, but we don't know the volume. However, using this formula here, pressure times volume being constant, we can work out the volume. So we can write it out like this. We can write P1V1 equals P2V2, which means pressure before times volume before equals pressure after times volume after, because PV is a constant. So we're trying to calculate the second volume, V2. I can rearrange this to get V2 is P1V1 over P2. So P1 is 50, V1 is 20, P2 is 25. Put those figures into my formula and I get the volume now being 40 meters cubed. You can also simplify that a little bit without doing the formula. You could just look at it as being the pressure is halved. So to keep P1 and V1 multiplied together being the same, if you half the pressure, that means you double the volume in order to do that. And just a quick reminder of the graph. So pressure times volume looks like this. You can also plot 1 over volume against pressure, and you get a straight line graph here through the origin. So two very quick Boyle's law questions. Give you a minute to read them. Have a go at them yourself. Okay, and the answer to the first one, again, we're using the same formula as before. P1V1 equals P2V2. V2 then is P1V1 over P2. So 20 times 3 divided by 4, which gives me 15 meters cubed. Here, we're asked to work out the pressure this time. So again, same formula. This time we're rearranging to get P2, which is P1V1 divided by V2. So the pressure one is 10 pascals. The volume initially was 9 meters cubed. It's reduced down to 1.5 meters cubed, so that's V2. Put our numbers into the equation and we get 60 pascals. Okay, so I'm going to put on a paper. So that's the end of the teaching for the second learning objective, describing and explaining how to change the pressure in a gas. Here is a paper 2 exam questions. So a liquid is heated, which statement is incorrect? Well, the liquid itself will expand. However, each individual molecule will not. The space between the molecules will, but not the actual liquid. So the molecules themselves expanding is false. Second question. A cylinder of constant volume contains a fixed mass of gas. The gas is cooled. What happens to the pressure of the gas and what happens to the kinetic energy of the gas molecules? So when you cool it down, you get two things happening. The pressure decreases and the kinetic energy also decreases. So the answer is A. Multiple choice question 3. So this is a more maths-based question from paper 2. A fixed mass of gas has a volume of 25 centimeters cubed. The pressure of the gas is 100 kilopascals. The volume of the gas is slowly decreased by 15 centimeters cubed. So it's decreased. It's not decreased to 15 centimeters cubed. It's decreased by 15 centimeters cubed. So that means the new volume is going to be 10 centimeters cubed because it's gone from 25 to 15. What is the change in the pressure of the gas? So again, P1V1 equals P2V2. Put the numbers in here. So the one we didn't know was P2. Rearrange that, so you'll get 100 kilopascals times 25 divided by 10, which gives you this number here, or 250 kilopascals. So the change in pressure, though, so that is the new pressure, but it asks for a change in pressure. So we have to subtract that from the original pressure of 100 kilopascals, which gives 150 kilopascals. Okay, and now for the last of the multiple choice questions, very similar to the graphs I showed you earlier. The graph shows how the pressure of a fixed mass of gas varies with the volume at a constant temperature. What is the volume of the gas when the pressure is 25 kilopascals? So we know that when it is 100 kilopascals, we've got a volume here of 10 centimeters cubed. So when it is 25 here, so we've got 100 times 10 equals 25 times V2. We rearrange to take the 25 over to the other side. So it's 100 times 10 divided by 25, which gives 40 centimeters cubed. Okay, so now I'm going to give you an exam style question. So this is a past paper exam question, but it's not a Cambridge one to start us off. Okay, I'll give you a second just to read through that. Okay, so go for it one little part at a time. What's the smallest change in volume that the syringe can measure? Also known as the resolution. It's 1 centimeter cubed. There's a little typo here. What type of variable was the mass of the gas? It shouldn't have centimeters cubed on there. It's the name of a variable, so that is a control variable. What conclusion can the student make from figure 2, this picture here? Use data from figure 2 in your answer. Give reasons for your answer. So pressure is inversely proportional to volume is the first mark, but it says use data from the figure. So you have to give an example. So I'll give an example here. So 8 times, so we're using a volume of 8 times 200 is 1600. And another example here. So when the volume is 10, the pressure is 160. So 10 times 160 is also 1600. Okay, so that is for the 3 marks for this question. And the final one for 4 marks is a explain question. So explain, which just means why something happened. So explain why the pressure in the gas increased as the gas is compressed. Okay, so as the gas is compressed, the volume of the gas decreases. So there are more frequent collisions of the gas particles with the container walls. Again, the key bit there is the container walls. Not just collisions, you have to make it very clear the collisions are happening with the walls of the container. And each particle collision with the wall causes a force. So there is a greater force on the walls for 4 marks. Okay, last question. So this is a Cambridge paper 4 past paper question. I'm putting the question on here. I'll just give you a moment to read it yourself. Pause it. Okay, and now I'll put the mark scheme on. Just be clear, for the calculation, if you just put 200 centimeters cubed, you should get all 3 marks just for that alone. So you get 1 mark for that. If you've got this here as your final answer, then you should get all 3 marks for that alone. Okay, next lesson, we've got Brownian motion. I will post a link to that below. Thank you very much, everyone. Have a great day, and I'll see you for the next lesson.